Ground-mounted transformers in pools of rainwater present a significant hazard. Rainwater can potentially cause electrical shock or grounding issues if it comes into contact with the transformer. It is recommended that transformers be elevated off the ground to prevent rainwater pooling around them. After a heavy thunderstorm, it's recommended to inspect electrical equipment for any signs of water damage or corrosion. Older panel boards with exposed copper components also pose a risk. Exposed copper components can create a risk of electrical shock or fire if they are touched or come into contact with other materials. Exposed copper components should be covered or enclosed to prevent accidental contact. It's difficult to determine the age of a panel board from a photo, but based on the design, it appears to be at least a few decades old. It is important to ensure that equipment is properly grounded to prevent electrical hazard. Regularly check for signs of corrosion on the transformers and panel board, as this can weaken the components and increase the risk of electrical problems. It is important to regularly inspect electrical equipment, especially after major weather events, to identify any potential issues. When dealing with electrical equipment, safety is paramount. Firstly, always de-energize equipment before performing any work. Secondly, use appropriate personal protective equipment, including insulated gloves and safety glasses. Thirdly, never work on electrical equipment in wet conditions. Fourthly, be aware of the potential for arc flash and arc blast, which can cause serious injury or death. Fifthly, if you are not qualified to work on electrical equipment, seek the assistance of a qualified electrician. Electrical grounding is a critical safety measure that helps to protect people and equipment from electrical shock. Grounding provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and interrupting the flow of electricity. This helps to prevent electrical shock and fire. Grounding systems typically consist of a grounding electrode, such as a ground rod or ground plate, which is connected to the earth. The grounding electrode is connected to the electrical system through a grounding conductor. All metal enclosures and equipment must be bonded to the grounding system to ensure that they are at the same electrical potential as the earth. Corrosion is a common problem in electrical systems, especially in damp or corrosive environments. Corrosion can weaken electrical components, increase resistance, and lead to electrical failures. To prevent corrosion, it is important to protect electrical equipment from moisture and corrosive substances. This can be done by using corrosion-resistant materials, applying protective coatings, and providing adequate ventilation. Regularly inspect electrical equipment for signs of corrosion and replace any corroded components. Electrical inspections are essential for identifying potential electrical hazards and ensuring the safe operation of electrical equipment. Electrical inspections should be performed by qualified electricians who are trained to identify electrical problems. During an electrical inspection, the electrician will check for things such as damaged wiring, loose connections, overloaded circuits, and improper grounding. The electrician will also test electrical equipment to ensure that it is functioning properly. Any electrical problems that are identified during the inspection should be repaired immediately. Transformers are electrical devices that are used to step up or step down voltage levels. Transformers consist of 2 or more coils of wire that are wound around a common core. When alternating current flows through one coil, it creates a magnetic field that induces a voltage in the other coil. The ratio of the number of turns in the 2 coils determines the voltage transformation ratio. Transformers are used in a wide variety of applications, including power distribution, industrial equipment, and electronic devices. Electrical panels, also known as distribution boards or breaker panels, are used to distribute electricity to different circuits in a building or facility. Electrical panels contain circuit breakers or fuses that protect each circuit from overcurrents. Electrical panels also provide a convenient location for disconnecting power to individual circuits for maintenance or repair. The electrical panel should be properly sized to accommodate the electrical load of the circuits they serve. It is important to avoid overloading circuits, as this can cause the circuit breaker to trip or the fuse to blow. Overloading circuits can also create a fire hazard. Electrical wiring is used to carry electricity from the electrical panel to the various electrical devices and equipment in a building. Electrical wiring must be properly sized to carry the electrical current of the circuits it serves. It is important to use the correct type of wiring for the application. For example, some types of wiring are designed for use in dry locations, while others are designed for use in wet locations. All electrical wiring must be installed in accordance with the National Electrical Code. Electrical codes and standards are developed to ensure the safe installation and operation of electrical equipment. The National Electrical Code, also known as NEC, is the most widely adopted electrical code in the United States. The NEC provides detailed requirements for the installation of electrical wiring, equipment, and systems. Electrical codes and standards are constantly evolving to keep pace with new technologies and safety concerns. It is important to stay up to date on the latest electrical codes and standards. Electrical safety training is essential for anyone who works with or around electrical equipment. Electrical safety training teaches people how to identify electrical hazards and how to work safely around electricity. Electrical safety training should cover topics such as electrical grounding, electrical shock hazards, arc flash hazards, and lockout/tagout procedures. Electrical safety training can help to prevent electrical accidents and injuries. Lockout/tagout procedures are used to prevent accidental energization of electrical equipment during maintenance or repair. Lockout/tagout procedures involve disconnecting the equipment from its power source and installing a lock or tag on the disconnect switch to prevent it from being turned on. Lockout/tagout procedures are essential for protecting workers from electrical shock and other hazards. Arc flash is a dangerous electrical phenomenon that can occur when electrical current flows through the air. Arc flash can generate extremely high temperatures and pressures, causing serious burns, injuries, and even death. Arc flash hazards are often present in electrical equipment such as switchgear, panel boards, and motor control centers. To protect workers from arc flash hazards, it is important to conduct an arc flash hazard analysis and implement appropriate safety measures such as wearing arc-rated clothing and using insulated tools. Electrical PPE, or personal protective equipment, is used to protect workers from electrical hazards. Electrical PPE includes items such as insulated gloves, safety glasses, arc-rated clothing, and insulated tools. It is important to select the appropriate electrical PPE for the task at hand and to inspect the PPE before each use to ensure that it is in good condition. Insulated gloves are used to protect workers from electrical shock when working on or near energized electrical equipment. Insulated gloves are rated for different voltage levels and should be selected based on the voltage of the equipment being worked on. It is important to inspect insulated gloves before each use for any signs of damage such as cuts, tears, or punctures. Safety glasses are used to protect workers' eyes from electrical hazards such as arc flash and flying debris. Safety glasses should be worn whenever there is a risk of eye injury. Arc-rated clothing is used to protect workers from the thermal effects of arc flash. Arc-rated clothing is made from flame-resistant materials that can withstand high temperatures. It is important to select arc-rated clothing that is appropriate for the arc flash hazard level. Insulated tools are used to protect workers from electrical shock when working on or near energized electrical equipment. Insulated tools are made from non-conductive materials and are designed to prevent electrical current from flowing through the tool and into the worker. It is important to use insulated tools that are rated for the voltage of the equipment being worked on. The NEC, or National Electrical Code, is a set of standards for the safe installation of electrical wiring and equipment in the United States. The NEC is updated every 3 years and is widely adopted by state and local jurisdictions. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It is important for electricians and other electrical professionals to be familiar with the NEC and to follow its requirements when installing electrical systems. NEC Article 250 covers grounding and bonding. NEC Article 300 covers wiring methods. NEC Article 310 covers conductors for general wiring. NEC Article 408 covers switchboards and panel boards. NEC Article 430 covers motors, motor circuits, and controllers. NEC Article 450 covers transformers. NEC Table 310.16 provides ampacity ratings for conductors. Electrical troubleshooting is the process of identifying and resolving electrical problems. Electrical troubleshooting requires a systematic approach and a good understanding of electrical circuits and equipment. Some common electrical troubleshooting techniques include visual inspection, voltage testing, continuity testing, and resistance testing. It is important to follow safety precautions when troubleshooting electrical problems, such as energizing the equipment and using appropriate PPE. Visual inspection is a simple but effective way to identify many electrical problems. Visual inspection involves looking for things such as damaged wiring, loose connections, and signs of overheating. Voltage testing is used to determine whether voltage is present at a particular point in a circuit. Voltage testing can be used to identify open circuits, short circuits, and other electrical problems. Continuity testing is used to determine whether there is a continuous path for current to flow in a circuit. Continuity testing can be used to identify broken wires, loose connections, and other electrical problems. Resistance testing is used to measure the resistance of a circuit or component. Resistance testing can be used to identify short circuits, open circuits, and other electrical problems. Electrical maintenance is the process of keeping electrical equipment in good working order. Electrical maintenance includes tasks such as cleaning equipment, tightening connections, and replacing worn parts. Regular electrical maintenance can help to prevent electrical problems and extend the life of electrical equipment. Infrared thermography is a technique that is used to detect hotspots in electrical equipment. Hotspots are areas of abnormally high temperature that can indicate a potential electrical problem. Infrared thermography can be used to identify loose connections, overloaded circuits, and other electrical problems. Power quality is a measure of the quality of the electrical power that is delivered to a building or facility. Poor power quality can cause electrical equipment to malfunction or fail. Some common power quality problems include voltage sags, voltage swells, harmonics, and transients. Power quality monitoring equipment can be used to identify and diagnose power quality problems. Surge protection is used to protect electrical equipment from voltage surges. Voltage surges are sudden increases in voltage that can damage or destroy electrical equipment. Surge protection devices, or SPDs, are designed to divert voltage surges away from sensitive electrical equipment. SPD should be installed at the service entrance of a building and at individual electrical devices. Harmonics are unwanted frequencies that can be present in electrical power systems. Harmonics can cause electrical equipment to overheat and malfunction. Harmonic filters can be used to reduce the level of harmonics in electrical power systems. Uninterruptible power supplies, or UPSs, are used to provide backup power to electrical equipment in the event of a power outage. UPS typically consist of a battery and an inverter. When the power goes out, the UPS automatically switches to battery power, providing uninterrupted power to the connected equipment. Generators are used to provide backup power to entire buildings or facilities. Generators are typically powered by diesel fuel or natural gas. When the power goes out, the generator automatically starts up and provides power to the building. Electrical energy efficiency is the process of using less electricity to perform the same tasks. Electrical energy efficiency can save money on electricity bills and reduce the environmental impact of electricity generation. Some common electrical energy efficiency measures include using energy-efficient lighting appliances and equipment. Power factor correction is the process of improving the power factor of an electrical system. Power factor is a measure of how efficiently electrical power is being used. A low power factor can result in increased electricity bills and reduced system capacity. Power factor correction can be achieved by installing power factor correction capacitors. Demand response is a program that allows electrical customers to reduce their electricity consumption during peak demand period. Demand response programs can help to reduce the strain on the electrical grid and prevent power outages. Smart grids are advanced electrical grids that use digital technology to improve the reliability, efficiency, and security of the electrical power system. Smart grids can provide real-time information about the status of the electrical grid and can enable more efficient use of electrical power. Renewable energy sources, such as solar power and wind power, are becoming increasingly important in the electrical power system. Renewable energy sources can help to reduce the reliance on fossil fuels and reduce the environmental impact of electricity generation. Solar power is the conversion of sunlight into electricity. Solar panels are used to capture sunlight and convert it into electricity. Solar power is a clean and renewable energy source. Wind power is the conversion of wind energy into electricity. Wind turbines are used to capture wind energy and convert it into electricity. Wind power is a clean and renewable energy source. Electrical safety is a critical concern in all aspects of the electrical industry. It is important to follow safe work practices and to use appropriate PPE when working with or around electrical equipment. Electrical accidents can be prevented by following these guidelines.